Angular acceleration. In physics, angular acceleration refers to the time rate of change of angular velocity. As there are two types of angular velocity, namely spin angular velocity and orbital angular velocity, there are naturally also two types of angular acceleration called spin angular acceleration and orbital angular acceleration, respectively. Spin angular acceleration refers to the angular acceleration of a rigid body about its center of rotation, and orbital angular acceleration refers to the angular acceleration of a point particle about a fixed origin. Angular acceleration is measured in units of angle per unit time squared and is usually represented by the symbol alpha. In two dimensions, angular acceleration is a pseudoscalar whose sign is taken to be positive if the angular speed increases counterclockwise or decreases clockwise, and is taken to be negative if the angular speed increases clockwise or decreases counterclockwise. In three dimension, angular acceleration is a pseudo vector. For rigid bodies, angular acceleration must be caused by a net external torque. However, this is not so for non-rigid bodies. For example, a figure skater can speed up her rotation, thereby obtaining an angular acceleration simply by contracting her arms and legs inwards, which involves no external torque. Particle in two dimensions. In two dimensions, the orbital angular acceleration is the rate at which the two-dimensional orbital angular velocity of the particle about the origin changes. The instantaneous angular velocity at any point in time is given by angular velocity is equal to the orbital angular rate. It is equally orbital angular acceleration is equal to the angular velocity per unit time. Therefore, the instantaneous angular acceleration of the particle is given by alpha is equal to d by dt v divided by r.